The Temperzone Outdoor Unit Controller, or OUC as it is commonly known, is a pre-programmed electronic controller of the outdoor unit's refrigeration system, complete with system protection features. The features that the OUC encompass are compressor cycling protection, compressor minimum runtime, high pressure protection, low pressure protection, loss or shortage of refrigerant protection, head pressure fan speed control, indoor coil icing protection, run and fault LED indication, remote common fault output, and repeat fault lockout protection. The OUC connects to mains power via the unit's control circuit, and through signals received from the thermostat, initiates the compressor and condenser fan according to system status. High and low pressure safety switches connect directly to the OUC and are direct acting. An amber LED in the centre of the OUC informs that power is connected to the OUC. System monitoring and fault detection is by way of 3 colour-coded individual sensors. Firstly, the red lead service valve sensor, which is located in a pocket on the suction line between the service valve and the reversing valve on split systems, or suction line from the evaporator to reversing valve on package units. Secondly, the yellow lead HP sensor, which is located in a pocket on a return bend of the condenser coil. And finally, the blue lead De-ice sensor, which is located towards the bottom of the condenser coil embedded in the coil fins. The OUC also incorporates a series of LEDs that are designed to indicate system status and operation, as well as any possible faults that may arise. Let's run through the various LEDs and their functions in detail. Firstly, we have 3 operation status green LEDs, which are located towards the centre of the OUC. These particular LEDs indicate current running status of the DI cycle, condenser fan and compressor. It is always best to check these LEDs when troubleshooting, as they are clear verification as to what should or should not be running. There are also a series of LEDs located on the far right-hand side of the OUC. These LEDs indicate DI status for reverse cycle operation, as well as various safety trips and sensor faults. The DI stop LED indicates outdoor coil temperature at or above 12 degrees C. The stop LED is always illuminated whenever the outdoor coil temperature is above 12 degrees. This is whether the unit's compressor is running or not. The DI start LED indicates outdoor coil temperature is at or below -4 degrees C. If neither start nor stop LEDs are illuminated, condenser coil temperature must be between -4 and +12 degrees C. The frost LED indicates service valve suction temperature is at or below -10 degrees C on the cooling cycle. The HP LED indicates high pressure failure via the high pressure switch. The LP LED indicates either low pressure failure via optional low pressure switch or shortage of refrigerant detection through system superheat monitoring. Temperature sensing is a far more accurate method of detecting refrigerant shortage using one or more of the 3 OUC sensors. It must be remembered, high superheat ultimately kills compressors. The remaining 3 LEDs deal with the sensors. The service valve sensor LED indicating service valve sensor fault. The head pressure control sensor LED indicating head pressure control sensor fault. And finally, the de-ice sensor LED indicating de-ice sensor fault. A sensor fault could be a short or open circuit, or sensor resistance is out of acceptable range. When power is first switched on to the OUC, or whenever the power is removed then restored, the OUC performs a quick system check by flashing the column of LEDs on the right-hand side of the OUC from outside to centre and back for a period of 15 seconds. Immediately following the system check, the last detected fault will flash for a period of 45 seconds. This feature allows the service technician to isolate the power before safely removing the electrical panel. In this instance, the unit's last recorded fault was an LP trip. There are 2 built-in safety timers associated with the compressor, a minimum compressor run timer which is designed to ensure the compressor runs for a minimum of 90 seconds. This ensures oil return to the compressor. If the compressor signal is removed from the compressor terminal in under 90 seconds, the column of LEDs will flash from top to bottom to advise minimum run timer has been activated. This timer is not adjustable. There is also a compressor anti-rapid cycle timer. When the compressor cycles off via the thermostat or the system is switched off, the compressor cannot restart for a minimum period of 3 minutes. If the thermostat calls for the compressor to restart, or if the system is switched back on during the 3-minute period, the LEDs will flash from bottom to top to advise that the anti-rapid cycle timer has been activated. This timer is also not adjustable. The combination of both timers maintains a maximum of 10 starts per hour. Located just below the column of LEDs is the test button. The test button functionality is as follows. By pressing the test button for a full 12 seconds in any mode, the OUC will be set in a commissioning mode. This reduces many of the running timers so that commissioning can be done without continuously being impeded by the time delays each time the compressor and heat signals are switched. The commissioning mode is allowed to run for 30 minutes, after which time normal operation resumes. While in commissioning mode, the column of LEDs will flash once every 5 seconds. Pressing the test button for 1 second in the dead zone, or when the thermostat is off, will run a brief test function which is designed to test the various LEDs as well as running the condenser fan and compressor for a few seconds. Relays and contactors will also be seen or heard switching. Once the test function is complete, normal operation will be resumed. When in the heat cycle, it is possible to test and confirm that the de-ice function is working correctly. By pressing the test button for 2 seconds, the de-ice limit timer of 30 minutes is inhibited, and de-ice should occur whenever -4 degrees coil temperature is reached and the amber start LED is illuminated. This test should prove that the de-ice control is functioning correctly and that the sensor is reading correctly. Pressing the test button for 5 seconds in the heat cycle will action an immediate de-ice cycle, even if the start LED is not illuminated. This test, however, can only be performed if the ambient temperature is not too high and the stop LED is not illuminated. The OUC also includes remote common fault output via an optional fault relay board. The optional board comprises of 3 voltage-free contacts that can be connected to common fault indication circuit or alarm. Each Temperzone unit that has an OUC fitted has a dedicated vacant position on the electrical panel to accept the mounting post of the optional fault relay board. What we see here is an LP trip, which has activated a remote lamp via the fault relay board. The OUC also has built-in head pressure control to maintain a condensing temperature of 38 degrees C in the cooling cycle for R410A units. This feature allows the unit to perform at ambient temperatures lower than 20 degrees C without the risk of damaging the compressor. The condensing temperature is measured by the yellow sensor, which, as previously mentioned, is located in a pocket on a return bin of the condenser coil. Depending on the ambient temperature, the condenser fan speed is ramped up or down accordingly. Another feature on the cooling cycle is the inclusion of indoor coil ice-up protection. Whether it be dirty or blocked return air filters, low indoor air quantity, belt or motor failure, the Frost Protect feature will shut the compressor down for 15 minutes. The suction temperature is measured by the red service valve sensor. Shutdown will occur when the red service valve sensor detects a temperature of -10 degrees C. Repeated consecutive trips will result in the compressor locking out until power is removed and restored to the unit. High pressure protection is activated via the traditional type high pressure switch. If the high pressure switch should open circuit, the compressor will shut down for 3 minutes. Confirmation of a HP trip is via the HP LED. As with the Frost Protect feature, repeated consecutive trips will result in the compressor locking out until power is removed and restored to the unit. Low pressure protection is only applicable if an LP switch is fitted. Larger commercial and some custom-built units are the only units likely to have an optional LP switch fitted. An open circuit LP switch will shut the compressor down for 3 minutes and the activation of the LP LED. However, a more accurate method of refrigerant loss or shortage has been designed into the OUC. On the cooling cycle, the temperature at the service valve, which is on the suction side, is compared to the temperature of the HP sensor, and should there be insufficient temperature difference, indicating loss or shortage of refrigerant, then a fault is indicated via the LP LED, and the compressor will be shut down temporarily. The most likely cause of an LP trip will be high superheat. Temperzone recommend a system superheat of between 3 to 5 degrees C. On the heating cycle, the temperature at the service valve, which is now on the discharge side, is monitored, and should this reach too high a temperature, indicating loss or shortage of refrigerant, then again the compressor will be shut down temporarily. Again, a repeated trip will result in the compressor locking out until power is removed and restored to the unit. De-icing is now achieved through the OUC, as opposed to the previous standalone Temperzone electronic de-ice control. Every 30 minutes from the end of a previous de-ice cycle, the de-ice cycle will be initiated if the outdoor coil temperature is at or below the lower limit. The green de-ice LED will illuminate, indicating de-ice cycle is operating. The compressor pauses at the start of every de-ice cycle. The outdoor fan stops, and during this pause, the reversing valve de-energises. The compressor then restarts and the de-icing commences. The de-ice start LED will go off as the temperature of the outdoor coil rises above the lower limit during the de-ice cycle. Eventually, the amber de-ice stop LED should illuminate, indicating coil temperature has reached the upper limit. The green de-ice LED will go off as de-ice terminates. The compressor pauses at the end of every de-ice cycle. During this pause, the reversing valve re-energises and the compressor and fans will restart. Normal heating operation is now resumed. The OUC has 4 dip switches. The dip switches are factory set in accordance with the product type that the OUC is fitted to. Detailed information on the dip switch settings can be found in the OUC Operation and Fault Diagnosis booklet, which has been included in today's information pack. Each OUC has its particular version program number affixed to the microchip, which is directly adjacent to the column of LEDs. There is also a release number which is located in the top left-hand corner of the OUC. This combined information will need to be supplied to technical support staff to aid in troubleshooting potential problems. Provision has been made for a serial communications port, which allows for the downloading of operational history should the need arise. Also included in the information pack is support information designed to assist with troubleshooting in more detail. This information is constantly updated and is available to download from the temperzone.biz website. That concludes the OUC presentation. Thank you.